All right, ladies and gentlemen, it looks like I should be live now. Um, there's typically a little bit of a delay with these things, so something like 10 to 15 seconds or something like that. So if you don't see me responding to a question right away or something like that, that's totally normal. It'll take me a few seconds. I've got it set up, so hopefully you can see that. So I've got the review that we're working on in the taking up the majority of the screen, and then I've got the chat window and just myself there too. So yeah, that should put us at good to go. If anyone is here, if you could just type something in the chat so I know that someone is actually watching and I'm not just doing this for myself. It's okay if I'm doing this for myself too. I'll still go through it, and make sure it's kind of going well. It looks like we got all sorts of people here. So okay, it is officially 8 o'clock, so we are going to get started. If at any point you have a question, just type something into the chat window and let me know. It's looking to me like things might be a little bit blurry, so I'll try to make sure I zoom in a little bit and kind of make sure that things are looking about as clear as I can get them. There's only so much I can do. I mean, I'm on home Wi-Fi, so. Anyways, let's take a look and take a look at these. If you have questions, let me know. So we'll start with, actually, I'm going to start not with this. What I'm going to start with is talking about basically just factoring rules and how we know what set of rules we should be following, okay? Really, the basic thing comes down to you should be looking at the number of terms. Okay, that's kind of the initial question you should be asking yourself is how many terms does a polynomial have, okay? And if it has two terms, so it's a binomial, you're going to either use squares or cubes rule. Okay, those are the only two choices you have with two terms, okay? And if it's three terms, you are going to be, we either call those door problems or we call them split the middle. Those are the only two choices there. And if it's four terms, it's going to be grouping for sure. Okay, that's kind of the basic idea there. And we'll talk about as we see them, as we see things that have two terms and three terms and four terms, and we'll talk about kind of how we can make sure we're recognizing those appropriately. And the big thing to remember in all of this is that you always want to GCF first. Okay, you want to make sure that you're actually trying to find the GCF of the polynomial first, if there is one. Okay, so now looking at the review itself, our first one is a door problem. Okay, I can recognize it because it's three terms, and it begins with just a regular x squared. Okay, so we are simply looking in a door problem for numbers that multiply to the last number and add to the middle number. So we're looking for numbers that multiply to 63 and add to 16. Okay, so I know that that's 9 and 7. Okay, and what I do with the numbers 9 and 7 is really pretty easy. I put them in parentheses with some x's and the appropriate signs. Okay, everything's positive, so it's x plus 7 and it's x plus 9. And that's the whole thing. You are absolutely done after that. There's no more work you need to show. That's it. It's x plus 7, x plus 9. You could write it the other way too. It could be x plus 9, x plus 7. Okay? Number 2 shows another one with three terms, but this one is one that we would call splitting the middle term. Okay? The reason we would call this one splitting the middle term is because it begins with a coefficient. Okay? That is not 1. Okay? So, what you have a couple choices there. Okay, you could do guess and check, or you can do split the middle term. I'll show split the middle term, and then I'll go back and re-explain guess and check. Okay, so split the middle term would involve you multiplying the first and the last coefficient. Okay, so when I multiply 4 and 15, I get 60. And then I'm doing similar math to what I did before, actually. I'm finding two numbers that multiply to 60 and add to the middle term, which is negative 16. Those two numbers that multiply to 60 and add to negative 16 are negative 10 and negative 6. Okay, so what I'm going to do with that then is I'm going to, as it's called, split the middle term. Okay, so I'm going to take that negative 16n and I'm going to break it up into negative 10n and negative 6n. The order you do those in should not matter at all. Okay, and I'm going to keep my 4n squared and my 15. Those I'm going to keep in there. Now what I'm doing is basically what I'm going to end up doing later on for the factoring by grouping problem. Okay, and what I'm going to do is I'm going to group those two together, and I'm basically going to factor out a GCF of both of them. Okay, so my GCF of 4n squared and 10n is 2n. When I take it out, I get 2n minus 5. Okay, same thing for the second batch. I'm going to take out a GCF of negative 3. I'm making it a negative 3 because then I know I'll get a positive 2n and a negative 5, and those parentheses will match. Remember, that's kind of our big check there, is I need those two parentheses. Let me get a different color. I have lots of fancy colors sitting here, so I might as well use them, right? That is kind of our check in this whole process. We know we did it right if those two parentheses that I've just underlined in blue match up, okay? And they do. So my final answer then is 2n minus 3, so that's the stuff that was on the outside, and 2n minus 5, that's the stuff on the inside. And that's the whole thing. Okay, so that's the work you'd have to show if you were doing splitting the middle. If you are a guess and check person, this is simultaneously a little bit easier / a little bit harder. Okay, so what you're going to do there is you are basically going to start trying to guess your answer, but you're going to guess something that makes sense, okay? So I see that, and I'll kind of try to do this work above the problem because that's where I got some room. I start with 4n squared in my problem, so I'm going to basically, in my two parentheses, I need to put something there that multiplies to 4n squared. So I could put 4n and n, or I could put 2n and 2n. Now, I kind of cheat because I know what the answer is right now, okay? But I'll, for the sake of argument, I'll pretend I put 4n and n, okay? That's obviously going to be wrong, but bear with me, okay? And then same thing with 15. I've put two numbers in there that multiply to positive 15, and if I'm smart, I'll put two negatives because I see that negative in the middle, so I'll probably guess that it's two negatives then, right? So I'll use negative 3 and negative 5. Okay, and then really the way you check is you know your first term, so the 4n squared is good, and you know that the 15 is good. You just don't know if the middle term is good. So basically what I'm going to do is I'm going to do 4n times negative 5. That's negative 20n, and I'm going to do negative 3 times n, and that's negative 3n. That gets me negative 23n. Okay, that's not negative 16n. And I basically would just keep trying different numbers that I know work until I got something that made sense, okay? So then eventually I would switch it, and I would do 2n and 2n, and then sure enough, if I multiply those together, I get negative 10n, I get negative 6n, and it works out, okay? That's kind of the first two problems. So yeah, again, as always, keep letting me know if you have any questions there. Okay, hopefully this is all turning out okay, but it looks like so far it is. Okay, moving on. The next two problems, let's see if I can get those in my window here. There we go. Our next two problems are our two-term problems, okay? So obviously one of those is squares rule and one of those is cubes rule, okay? The first one is squares rule. 9 and 25 are perfect squares. The big things to remember about squares rule, both numbers have to be perfect squares, and it has to be subtraction in the middle. Okay, if it's not subtraction in the middle, it does not work. So this one does meet all of our criteria there. Okay, so we should be good. So then basically all you do for squares rule is you basically try to write the same numbers in there twice. Okay, so basically what I'm going to put first is two of the same thing, like I'm basically taking the square root of 9n squared, and I'm putting that here and here. That's probably a little better now that we've actually done some work with roots. And then same thing for the 25. I'm going to use 5 times 5. I can't use any other combination because I got to make sure I use two of the same number. Okay, and then I'm putting opposite symbols in there, so one's a plus and one's a minus. And that's literally the whole thing. Okay, that's the whole thing for squares rule. Again, if you see a plus sign, it's prime. If one of them's not a perfect square and it's supposed to be squares rule, it's prime. We'll look at the other option for binomials in a second. Ali asked a good question. Do we need to know split the middle term for final exam, or can we just do guess and check? I am not going to force your method there. When we're talking systems of equations in a couple days, I think I've got a review on that scheduled for next week. Then I will totally tell you, you have to solve a substitution, you have to solve an elimination. But for factoring, do whatever you want. As long as it gets you the right answer, you're totally fine. Okay, so you can use whatever method you want there. Good question. Okay, next, 8r cubed plus 27. Okay, this is cubes rule. I don't know why I put this fourth. This is kind of a pain for the fourth problem, but let's do it. Okay, cubes rule. Okay, for it to work, it has to be a binomial, and everything has to be a perfect cube. It can be addition or subtraction. Okay, you'll notice 2 cubed is 8, and 3 cubed is 27, so that's a good sign. Like, this is for sure a cubes rule problem. It's a rule you're going to have to memorize. Okay, I will put the rule over to the side here. The rule is this. A cubed and B cubed is what you start with, so that's kind of like our starting problem. And then what it factors to is A, B, A squared, AB, and B squared. Okay. Now, I didn't put any actual symbols in the formula, and the reason is I can, but there's one set of symbols for plus and one set of symbols for minus, and we actually had an acronym that we used to remember these. Okay, you don't need to use an acronym, you could just kind of memorize them if you wanted to, but the acronym we used was SOAP. Okay, and what that stood for is same, opposite, always plus. Okay, so basically you're inputting 3 symbols in there. You're putting one between A and B, one between A squared and AB, and one between AB and B squared, right? So you're putting the same one in the first one, the opposite one in the second one, and the last one's always a plus sign. Okay, so let's look at what this looks like for this one. Basically, the big key to this is figuring out what your A and your B are. Once you figure out what A and B are, you're okay. Essentially, this whole thing is A cubed. Okay, so 8r cubed is A cubed, and 27 is B cubed. Okay, so from there, I just got to figure out what are my A and my B. Well, for 8r cubed, that's 2r. Okay, so my A is 2r. Because if I multiply 2r times 2r times 2r, I get 8r cubed. And my B is 3. Because 3 times 3 times 3 is 27. Okay, so now I just plop into the formula. Okay, so AB, so 2r and 3. Okay, we've got to be a little bit careful with like our A squareds. A squared very literally means A times A. So we're doing 2r times 2r, or we're squaring that. That's 4r squared. You do need the 4 there. It can't be 2r squared. It's got to be 4r squared. Okay. AB means A times B. So that's 2r times 3. So that is 6r. Okay. And then B squared is 3 times 3. So that's 9. Okay. And then to put your symbols in there, this is where you use SOAP. So same. So my first one's the same as my original. My original problem was a plus. So first one's a plus. My second symbol is the opposite of whatever I just wrote. So that's a minus because I just wrote a plus. And the last one, AP, always plus. Okay, so that's cubes rule. Okay. Okay, again, cubes rule only works if you have everything as a perfect cube, but again, that one can work with addition or subtraction. Aaron asked which parts of the exam are we not allowed to have a calculator? None of them. You can use a calculator on the whole thing. So enjoy that. You're welcome. Okay, moving on. We got 3 problems left, and again, let me know about questions as they come up. Okay, number 5, I think I got it in there. There we go. Is a factoring by grouping problem. It's 4 terms, so it's absolutely got to be factoring by grouping. Okay, so all I'm really doing is the same thing. If you're a splitting the middle term person, this is probably easy. Okay, and really, here's what we got. We're just underlining the first 2, underlining the second 2, and we're taking out some GCFs. This is literally what we did during splitting the middle term. Okay, and we get 20x cubed. Oh, nope, didn't take out GCF. Sorry, I was rewriting. Take out a 5x squared from 20x cubed, and we'll have a 4x left and a minus 5. Okay, same thing for the second 2. The GCF of 32x and 40 is 8. So I'm going to take out an 8. And I'm left with, you guessed it, 4x minus 5. Okay, combine those together, and we've got 5x squared plus 8 and 4x minus 5 because our parentheses did match. Okay, that was very, very similar to what we just did in splitting the middle term. I'm going to have to move my own face here, which is going to be weird. Let's see if I can do this. Oh, there we go. I didn't want to move my chat that far, though. I'll move the other window. Hang on 1 second. There we go. Move my face up to the top now. All right. Anna asked, do we have to do the distributive property after the cubes rule? Okay, so for all of these factoring problems, every single one of them, there should be no distributive property or anything like that afterwards. So like if we look at all of these, literally all of them, you just literally have to leave them as they are. Okay, so if you did distributive property on any of these, so like if you multiplied these back out in this first one, you would get x squared plus 16 plus 63. Same thing for the cubes rule one. These all look like awesome distributive property problems, and they are, but no, you shouldn't do distributive property because you're just going to get back to the original problem. You're basically undoing the distributive property. Okay, so that's a good question. Reagan asked, after cubes rule is finished and you fill in SOAP with the equation, are you done or do you have to simplify more? That is a really good question. Okay, I get asked that one a lot. Turns out I'll leave it really simple since we're approaching exam time and I don't want to overload you. But the only thing, unless you had a really strange problem, none of these will ever simplify. Okay, so unless you missed a GCF, I guess if you missed a GCF at the beginning, that could possibly be a problem. But really, that polynomial, that trinomial there, it looks pretty. It looks like a splitting middle term problem. That will not simplify. Okay, that is something you do have to potentially watch out for in other problems. It's not true here. You won't have to watch out for that at all. Okay, so good questions, guys. All right. Guys, give me 30 seconds. I have to go tell my kid to stop talking to himself. Think of some questions or something. Hang on. Sorry about that. My kid was trying to sing himself to sleep, and he was almost waking the other child. The joys of parenthood. Okay. So we are on number 6. Okay. Number 6 is actually not a significantly different problem, but if you notice, I threw some y's in there, okay, just to make sure that we knew how to deal with those, okay? There is absolutely almost no difference at all, okay? So if there were no y's in there, it would be a split the middle term problem. There are y's in there. It's still a split the middle term problem, okay? So I am going to, I'll do actual split the middle term here because I know a lot of you do that, but if you're a guess and check person, no big deal, okay? So I'm going to still multiply 3 and negative 80. I get negative 240. Okay, so I am looking for numbers that multiply to negative 240 and add to 22. Now, the one thing I'm going to tell you here before we move on is that really the big major difference here is that what's going to happen then when you split the middle term is when you split up this middle term here, you are basically going to have to put x's and y's on both of them. Okay, so let's look at what that looks like now. Big reveal in case you were kind of doing this along with us. The two numbers that meet this criteria are 30 and negative 8. Okay, those add to positive 22 and multiply to negative 240. Okay, so here's where this looks just a little bit different. Okay, it doesn't really matter what order you put them in. I'll go with the 30 first, I guess. So we're going to go 30xy and minus 8xy. Okay, so that's how we're splitting the middle term. An x and a y has to go on both of them. Okay, I stick my 3x squared and my negative 80y squared in there too. All right, then I'm just pulling out GCFs, same thing as always. So I'm pulling out a GCF of 3x, and I get x plus 10y. Notice how I've got some y's left in there. That's okay, that's fine. Okay, and then my second two, they're both negative, so I'm for sure going to take out a negative. I'll take out negative 8y. And when I do that, I get x plus 10y. That's my check step, and I get 3x minus 8y times x plus 10y. Okie dokie. Okie dokie. So really, nothing changed on that problem. And in any problem that has x's and y's in it, really, it's what would it be without the y's? Okay, and it's in most cases the exact same type of problem. Okay, couple random questions. How much time will we get for the exam? I will let you know that when we get closer. I'm working out a schedule so we can actually take it, but you will have plenty of time, so don't worry about that. Usually I try to give close to 2 hours. It's 20% of your grade, but like on report cards, you'll see a semester grade, a quarter grade, or an exam grade, and then a final grade. And the exam is June 1st, yes. So no, and all those exams will be on the same day. Okay, so I try to get them all the same day. And so unless something happens where I can't work out a schedule or something, you know, it'll be on June 1st and they'll all be the same day. Okay. And yeah, for you honors kids, 89.5 does round up. Okay. Try to save those kinds of questions for maybe in person. Okay, so people don't have to watch that later if they're watching later. Anyways, if you are watching later, welcome. All right, last problem. Okay, at first glance, this problem looks like a splitting the middle term problem. And that's exactly why I threw it on there, because it looks like a splitting the middle term problem. But as I think I did at least kind of a good job of saying at the beginning, we got a GCF first, right? Okay, and this one does have a GCF. Okay, if we look, this one has a GCF of 2. Okay, so I'm going to take out my GCF of 2 first, okay? Because if you don't, it just makes the problem a lot harder, and you still do have to get that GCF out before the end of the problem. Okay, so once you get that GCF out, you can kind of see that, oh, this is really just a door problem. Okay, so now we're just going to do the door problem. We're finding two numbers that multiply to 60 and add to 16. Those are 10 and 6. And because it's a door problem, we don't have to show any more work other than writing x plus 10, x plus 6. And then we just have to make sure that that GCF of 2 comes along. Okay, so that's all we should get for that last one. If you don't take out a GCF at the beginning of a problem, okay, so for this particular one, we could actually do that. We have a few minutes, so let's pretend you didn't, and instead you just did, okay, I'm going to switch colors here. Okay, so we did 2x squared plus 32x plus 120. Okay, so instead you miss it. And you're like, oh, darn, I think this is a split the middle term problem. Okay, and you're just going quick and you don't realize it. In most cases, you will be fine. Here's what will happen. Okay, so you'll do some kind of factoring. I'm going to go through this a little bit quicker just so we can get to the good stuff. Okay, I'm looking for numbers that multiply to 240 and add to 32. Those are going to be 20 and 12. 20 and 12. Okay, so it's 2x squared plus 20x plus 12x plus 120. I'll take out some GCFs. 2x, x plus 10, plus 12, x plus 10, and basically here's where you'll end up. You'll have 2x plus 12 times x plus 10. Okay, so I'll actually kind of let you guys take a second and think about this. Also be thinking of any last second questions you have. Let's keep them as much on factoring as possible, okay? So just, you tell me, that was one answer, and the answer I was supposed to get. I think I can fit those both on screen. Yeah, I sure can. The answer we were supposed to get is in purple over there. Okay, so you tell me, I mean, like, how do you think we could get from there to there? Okay, what we could do is we could basically do this. We could just take, over in that 2x squared plus 12, we would just factor that further. We would take out a GCF of 2 from there, and we'd be left with x plus 6, and the other one is still x plus 10. Like, we don't have to take out GCF from both. We just need to take one out from one. And then we get the exact same answer. Okay, so that's pretty cool. Dara asked, if you wait till the end to take out a GCF and both brackets have a GCF that need to be extracted, do you multiply those together? Yes. So if we had some weird situation where we had a final, or a not final, but like we had an answer at the end of maybe 2x plus 10 times 3x plus 6. We would take out a GCF of 2 from the first one and turn it into x plus 5, a GCF of 3. I didn't write that very well. Hang on. I'm going to go above it. My bad. And GCF of 3, and we turn into x plus 2. Okay, so we basically do that, and then yes, you would want to take that 2 and that 3 and multiply them together and just make it 6x plus 5, x plus 2. So yeah, if that weird situation happened, you would just kind of take care of it by doing that, and you would multiply them together. You don't even necessarily have to write them out separately like that. You could just kind of go straight and be like, yep, it's 6 because I'm taking a 2 out from one and a 3 out from the other. They do get multiplied, yes. Okay. No, Jason, you're not going to be allowed to have a note card. If there's anything I want you to have, I'll give it to you ahead of time, and we can talk about that as we get a little bit closer. We do have some time to talk about that kind of stuff. Okay, that's about it for factoring. Unless I hear questions in about the next 10 to 15 seconds or so, we are going to be all done. If you were watching this later, hope this was helpful, and feel free to see me if you have any questions at all. Same thing if you're watching it live. See me if you have any questions on this or if it's feeling like it's still a struggle. But that was a pretty comprehensive view on factoring. Okay? Thanks for tuning in, guys, and hope this was helpful. #math.